Hi guys, welcome back. So we got a brand new topic for today's lesson. We're talking about this idea of completing the square, which comes from section 8.8 in the textbook, if anybody still uses that. And I know this is probably, again, brand new to a lot of people, but I hope it makes sense by the end of this. Basically, let's see what this says here. I think I've said this before, that in general, we know already that not everything is factorable, all right? Which means not every quadratic equation in the world is able to be solved by factoring, all right? There's multiple other ways that you can solve a quadratic equation. We talked about solving a quadratic equation by taking square roots, and then method number 2 is talking about this idea of completing the square. All right, so someone had asked about this when we finished up factoring, but there was something that we had glossed over, which was this idea of perfect square trinomials. All right, I think you guys might remember from when we talked about factoring. I'm just going to make a note of this up here. Like if you had something like x plus 5 and x plus 5 as your final answer, the more simplified version of something that looks like that, because you have x plus 5 twice, is x plus 5 squared. All right? And if you FOILed this back out, you would be left with x squared plus 5x plus 5x plus 25, which when you combine like terms gets you x squared plus 10x plus 25. So this is like, this would be your original factoring problem, right? And this would be your final answer. So something like this is an example of what's called a perfect square trinomial, all right? And coincidentally, why they're called perfect square trinomials is because the final term in all of these trinomials are going to be perfect squares. Like if you look at these examples down here, we have the final term is 9. We have the final term is 16, all right? So that's sort of how we're going to start figuring out how to complete the square, all right? Our goal for these first few problems is going to be to figure out what this final term is, all right? We already have that kind of edge that we know it's going to be a perfect square, so it's going to come from this list that we used last week, but there is a procedure, all right? The procedure of completing the square is basically what it says here. All right, the final term of this trinomial is going to be whatever you get when you follow this formula. All right, b over 2 squared. Okay, so in this example, right, we already know that trinomials look of the form ax squared plus bx plus c. All right, so b is the coefficient of your x term. So our b value here is what's in red, it's 6. All right, so what's going to go in this blank space is whatever you get when you do 6 over 2 squared. And again, order of operations, so you do whatever's in parentheses first. 6 over 2, 6 divided by 2 is 3. Squared is 9. All right, this actually leads you into what we're going to talk about after we practice completing the square a little bit. This is how x squared plus 6x plus 9 is going to factor. All right, there is a shortcut in terms of how it factors. We'll talk about that later. All right, all it says here is to complete the square. All right, so all we're doing for these two separate problems is we're filling in these gray boxes. All right, by using that exact same b over 2 squared formula. All right, so this is your b value. 2 over 2 squared. That's all we're doing. 2 over 2 is 1, and 1 squared is 1. So filling in this trinomial, what goes in that gray box is just 1. All right? And that's all we'd have to do for the problem, because again, all it says is to complete the square. For something like part B, you do have to be cautious of your signs. All right? Negative 6 over 2 squared. Negative 6 over 2 is negative 3. But there is a reason why the parentheses are there. All right? We talked about this last week. Negative 3 squared is the same thing as saying negative 3 times negative 3. And a negative times a negative is a positive. So that's why there's always plus signs over here when you're completing the square. Because when you square numbers, no matter what sign they are, you should always get a positive. All right? Negative 3 squared is positive 9. Okay? And it would be the exact same thing. Oh, no, actually, I'm going to do this one later, but I want to talk about something like this for part B, just because things could be a little weird. Negative 5 over 2 squared. Now, what is negative 5 over 2? All right? Negative 5 divided by 2 is a decimal. It's negative 2.5. But I feel like I've said, if I haven't already said this at some point recently or some point during this school year, I believe later on in certain math classes, as you move through high school, there will be certain things that your teachers will rather you write in a decimal or rather you write in a fraction or an improper fraction. I think most of the time as you move up in math or as you move through math courses, most of the time people want things in an improper fraction. All right? So we're going to leave negative 5 over 2 as negative 5 over 2 because that fraction can't be reduced anymore. When you're squaring a fraction, though, you are allowed to square both the numerator and the denominator. So negative 5 squared is 25 over 2 squared is 4. So 25 over 4 is going to go in that gray box. All right? And that's it for completing the square. And we're going to talk about stuff like how this kind of relates to everything in a couple minutes. Because now we're actually talking about how to complete the square, all right? Or how to solve a quadratic equation by completing the square, all right? Even though the format is a little bit different, all right? You still have all your quadratic pieces, right? If you kind of remember from factoring, we wanted everything all over to one side to get equal 0. When we solved by taking square roots, we would want the squared term isolated. And here we want something that looks like this, where it says x squared plus bx equals c. All right. So we want every single variable term over to the left side of the equal sign, and we want all the numbers over to the right. That's how we want our setup. If we don't have that set up, we want to get that set up first. That's step 1. All right. So I'm just going to read this real quick, and then I think it might make more sense if we actually dive into an example. We're going to complete the square by finding b over 2 squared and adding it to both sides of the equation. That's important because, as I'm sure you guys remember from the beginning of the year, whatever you do to one side of the equation, you have to do to the other. All right, that doesn't change. Factor the trinomial, which is going to be on the left. Take the square root of both sides, and then we're going to proceed. The last step is just solving by square roots, which we did last week. All right? So here's what that means in terms of this problem. Problem 2a. We already have it in the form x squared plus bx equals c. We have all the variables on the left, and we have all the numbers on the right. Okay? So we want to add something else to both sides of the equation. So what I like to do is I actually like to put in those spaces for that something else. So kind of like we had a gray box with the last couple problems, I'm going to fill in plus blank. And because I have a plus blank on the left, I have to fill in a plus blank on the right because, again, whatever you do to one side of the equation, you have to do to the other. Okay? Now, how are we going to fill in this blank? Well, the same process that we did for completing the square in the last few problems. B over 2 squared. 16 over 2 squared. 16 over 2 is 8. 8 squared is 64. So this gets filled in with a positive 64. But again, whatever you do to one side, you have to do to the other. So if this gets filled in with 64, this does as well. Okay? Negative 15 plus 64, that's easy to figure out, is 49. Simplify that. And then we're going to factor the left. And this kind of brings in, where did it go? This whole idea from a couple slides ago, okay? You can absolutely sit there and figure out all the factors of 64 and figure out which pair adds up to positive 16. But you have, you have a shortcut, all right? The factors of 64 that add up to 16 are 8 and 8. And how do we get that really quickly without listing all the factors of 64? Just this 16 over 2 piece. That's what this is saying. Factoring a perfect square trinomial, it's going to be x plus or minus, depending on what the sign is, whatever you get when you divide your b value by 2. So our 16 divided by 2 is 8. So that means our factors would be x plus 8 and x plus 8. We could simplify that to be x plus 8 squared. And now this looks like a problem that we did last week with solving quadratic equations by taking the square root. We're going to take the square root of both sides. It cancels out on the left. So we have x plus 8 equals the square root of 49 is 7. But because we're actually evaluating the square root, this is what the this previous slide had said, both the positive and the negative square root. So it's really important that you do not forget about the plus or minus here, because then it's exactly the same thing that we did last week, splitting them up into two equations where one is plus 7 and one is minus 7. And then we're going to solve them both. This is 8. So x is negative 1 and x is negative 15. Those are your two answers, or they should be your two answers. This problem says to check your answers, so the same way we've been doing this entire time. We're going to take both of these one at a time, plug them back into the original. Okay? So be careful with your parentheses. Negative 1 squared plus 16 times negative 1 should be equal to negative 15. Negative 1 squared is 1. Minus 16 does equal negative 15. So that's good. Negative 15 squared plus 16 times negative 15 also should be equal to negative 15. Negative 15 squared is 225. We know it's going to be minus because positive times negative is negative, but I don't know. It's negative 240. Okay. So minus 240. And does that equal negative 15? Yes, it does. Sweet. Okay. All right. The exact same setup as before. We have it in the format we want. X squared plus bx equals c. So we can just go right ahead and start adding in those blank spaces. How do we fill in these blank spaces? B over 2 squared. So 10 over 2 squared. 10 over 2 is 25. 10 over 2 is 5. Squared is 25. So both blank spaces get filled in with the exact same thing. It's 25. Negative 9 plus 25 is 16. And this factors into, we know this is plus, so x plus 10 over 2 is 5 squared. Because again, factors of 25 that add up to 10 are 5 and 5. So it all works out. Take the square root of both sides. Cancels out. X plus 5 equals plus or minus 4. And then we're going to break it up. One positive, one negative, and then solve. And there we go. And we're getting up to 15 minutes, so again, for the sake of time, I'm going to hold off on checking the answer. That's how you do a problem like this. This one is exactly the same thing. So I will, again, you'll have a digital copy of all of these answers, but I'm going to post it later, and I'm going to skip this problem for the time being. All right. Here's the thing with this one. All right. It's not in the format that we want. We want x squared plus bx equals c. We want all the variables on the left and all the numbers on the right. So we have to do a little bit of manipulation before we can start. We do have both the variables on the same side. We just want the 6 over to the right. So it's pretty easy. We just add 6 to both sides. You get x squared minus 4x equals 6. And then from here, now that it looks like the format that we want, it's the exact same problem, or the exact same type of problem that we've been doing for the past several minutes. So we add in those blanks. And then we're going to do negative 4 over 2 squared. So negative 4 over 2 is negative 2. Squared is positive 4. So both of these are going to be filled in with a positive 4. Okay? 6 plus 4 is 10. We want it to be x minus because of this minus sign right here. And again, what are factors of 4 that add up to negative 4? Negative 2 and negative 2. So it's going to be x minus 2 times x minus 2, or x minus 2 squared. Okay? And again, it follows the negative b over 2 format pretty nicely. So now we can go in and solve by taking square roots. Cancels out. X minus 2 equals, now 10 is not a perfect square. All right? Is it possible to simplify the square root of 10 though? It's not. There's no factors of 10 that are a perfect square. You know, the only ones that we would be able to deal with are 9, 4, and 1. And dividing 10 by 1 doesn't change anything. So we still want that plus minus, but we're going to leave it as the square root of 10. Again, this is kind of the idea that I kept trying to make a point of last week, where we don't want any decimals in our final answers. Okay? And then to make your life a little bit easier, we can just add 2 to both sides, since we already have both the plus and the minus. And since we can't add 2 to 10, you know, just keeping it all in one nice format is going to make it look a little bit better and make our lives a little bit easier again in the long run. So x equals 2 plus or minus the square root of 10. As I said last week, you could easily break this up if you want to, if that makes more sense to you. But you don't have to, because even if you did 2 plus the square root of 10, you can't combine them. 2 plus the square root of 10, one's a square root, one isn't. They're not quote unquote like terms. So you would just have to leave it as 2 plus the square root of 10 and 2 minus the square root of 10. That's why, again, for me, I think it looks a lot nicer if you leave it like that. And yeah, that's that. I think, I don't know if there's anything else much left to talk about with these kinds of problems. Let me just think about this. Actually, I think I'm going to skip this one, and I'm going to do this one. Okay? It's the same kind of thing as before, with, it's not in the right format, but all you would have to do to get it in the right format is just add 25 to both sides. So now it is in the x squared plus or minus bx equals c format that we want. All right. So same thing as the last one we just did. We can add in the plus blank. And then same thing. We're going to do negative 10 over 2 squared. Negative 10 over 2 is negative 5. Squared is 25. So both blanks are going to be filled in with a 25. 25 plus 25 is 50. What are factors of 25 that add up to negative 10? -5, and -5. So x minus 5 squared, and it matches up with -10/2 is -5. Take the square root of both sides. So we have x minus 5 equals something. Now the thing with 50, and the reason why I wanted to do this one, is because the square root of 50 can be simplified. 50 is not divisible by 49, it's not divisible by 36, but it is divisible by 25. So since it has a factor that's a perfect square, we are able to simplify the square root of 50. Square root of 50 breaks down into the square root of 25 and the square root of 2. 25 is a perfect square, like we just said, so we can evaluate it. The square root of 25 is 5. So the simplified version of the square root of 50 is plus or minus 5 root 2. And I think I said this last week, but even if it doesn't tell you to simplify radicals, it's good math practice to always simplify radicals whenever you can. All right, so if you're dealing with radicals, you have to check to see whether or not you can simplify the radical before you do anything else. You have to. All right. But then this is the exact same as the last one, where we're just going to add 5 to both sides. It wouldn't really do you any good to split it up, because even though, like, you have, like, a 5 plus 5 and a 5 minus 5, the 5 is being attached to the root 2, all right? So you would have to treat the 5 root 2 as a whole number, all right? Please do not do 10 root 2. Please do not do 0 root 2, all right? It's the same kind of thing, because this whole term has a radical with it, you cannot do anything with it with the 5. It's got to stay 5 plus 5 root 2 and 5 minus 5 root 2. All right? And that's it for that problem. Okay. Now here's the thing. I kept saying x squared plus bx equals c. All right? And the emphasis was on x squared. All right? It has to be x squared. This is not going to work if you do not have x squared. So if you have a coefficient other than 1, you're going to want to have to divide it out. All right? I'm going to try to be nice with it and not give you any numbers or any equations where all the pieces aren't evenly divisible by whatever your leading coefficient is. So here's what I mean by that. We're going to have to do two things now to get the format that we want. We're going to have to divide everything by whatever the leading coefficient is in order to cancel it out. So that means everything here has to be divisible by 10. Or not necessarily it has to be divisible by 10, but you have to divide it by 10, whether it's divisible by 10 or not. The point I was trying to make was I will be nice, especially since online learning is still kind of in a weird spot. I'm going to be nice, and I don't think I'm going to give you anything where all of your terms will not be divisible by whatever the leading coefficient is. So something like this, where you can easily do everything divided by 10. This gets you x squared minus 2x minus 3 equals 0. And then it's the exact same thing that we just did, okay? Where we still have to do a little bit more work to get it into the format that we want, x squared plus bx equals c. Add 3 to both sides. X squared minus 2x equals 3. Put in your plus blanks. If you want to do the solving it and putting in the plus blanks in one step, that's absolutely fine. Negative 2 over 2 squared. Negative 2 over 2 is 1. Squared is 1. So 1. 3 plus 1, I'm going to move up here. 3 plus 1 is 4. Factors of 1 that added to negative 2 are negative 1 and negative 1. So x minus 1 squared. This works out nicely because when you take the square root of both sides, you get x minus 1. Sorry, I'm thinking ahead. 4 is perfect square. So when you take the square root of 4, it gets you nice whole numbers, plus or minus 2. And now you actually can go in and separate the two equations. X minus 1 equals 2. X minus 1 equals negative 2. So it's still the same thing where you should get 2 different x values because you're solving quadratic equations. And there you go. And as always, you can check by plugging both of these into the original problem and see if you do get 0. And if you do, you did it right. Okay? All right. I think this is going to be the last one. And again, I'm going to do any problems that I skipped over after this video ends, and they will be posted onto Google Classroom. All right? We want this leading coefficient to completely cancel out. All right? So we're not only dividing by 3 in this case, but we're dividing by -3. Okay? If you have something on this side, I didn't do that with the last one, but it's everything on both sides by -3. The only reason I didn't do that for the last one is because if you're dividing 0 by -3, you're going to get 0. If you have something on this side other than 0, definitely divide it by -3 as well, or whatever your coefficient is that you're dividing by. Okay, so x squared minus 4x, because you're dividing by a negative, so the signs are going to change, plus 5. Okay? Equals 0. And then again, everything else is the same. Move this over. Wow, this is approaching half an hour, so I'm going to combine a couple steps. Okay. Okay. B over 2 squared. -4 over 2 is -2. Squared is 4. Ah, interesting. Okay, so when you add up -5 plus 4, you get -1. This is actually a really interesting one to finish off with. Factors of 4 that add up to -4 are -2 and -2. So this is x minus 2 squared. And this is the thing that I hope a lot of people still realize, okay? Even though it does end up canceling out, what is the square root of -1? It doesn't exist. You cannot take the square root of a negative number. So because of that, there is no way that you can proceed with this problem beyond this point. So what does that mean when it asks you to solve? If you can't finish solving it, then there's no solution. Everybody's favorite answer. All right. And again, I'll do this one later. But that's it. All right. Same kind of thing as always, reach out if you need me. There's plenty of places for you to contact me if you need me. The big group hangout chat, the question forum. Not many people have signed up for Google Meet sessions, but if you need to, I would definitely recommend doing that. And yeah, I think I'm going to stop rambling. Stay safe out there. Talk to you guys soon.